All right, guys, we are doing the chapter 2.1 quadratics notes, quadratic functions. In class today, so that I didn't rush through the calculator part, we actually started on this page in the notes. So I'm going to do that for this video as well. All right, so quadratic regression. We have already done linear regression. So if you need a reminder on how to do linear regression in Desmos, please see the number 2 notes that we did with linear regression. This is basically the same thing. So we're not learning any new Desmos skills. I'm just reminding you how to answer some of these questions that we answered in the last chapter. So a study was done to compare the speed x in miles per hour with the mileage y in miles per gallon of an automobile. The results are shown in the table. Part A, use a graphing utility to create a scatter plot of the data. So let's use Desmos for this. All right, so if I'm using Desmos, maybe see if I can split screen here. There we go. So I can add a table, and I'm going to start typing in the x values. If there's a nice little linear pattern, the table will start filling in for you. All of these numbers are hit until we get to 75. And then I need to type these in. So I'm just going to try to do it carefully without typos. You should always scan your list to see if there are any typos. We're never going to have a giant list of numbers to enter in, so it's scannable. It shouldn't take you more than a few seconds to do. So again, I'm just going to check this very quickly. And if I catch a mistake, that's great. Okay, I think this looks okay. Once you enter in a table, to see your scatter plot, hit the zoom fit in the bottom corner here. There we go. This looks kind of like a parabola. I believe that. You still get regression by coming up here and clicking add regression. Now, the first thing it does is linear regression by default. This obviously is not a good model to represent this curved data. I want to point something out, actually. Linear regression is just the first thing that it does. Check out these statistics down here. We have not talked really about correlation very much in this class, but correlation is basically like if you have correlation of 0, then this is like a really bad model for the data. So the fact that this is close to 0 is shows it's a pretty bad model. Also, if the correlation R is close to 1 or -1, then that means that you have a really strong model. There's a big relationship between the points that you're looking at and the curve here. So, all right, so this is pretty bad. Let's click this drop-down box and change it to quadratic because this looks like a parabola. You can see the correlation. They don't give you R, but R squared is just, if I were to square root this, I would get R. That's a pretty strong correlation. It might be that one of these other models is better, but we are focused on quadratic. If you're doing regression on the AP pre-calc test, you will know which one to do. If you're allowed to use a calculator, you're not going to have to scroll through a bunch of these to find residuals. All right, so let's write this equation without rounding any decimals off. Let's go ahead and write this down for part B. So use the regression feature to find a model, write the equation, comment on the strength. I'll do that in a minute. But let me just write the equation first. Try to get this out of here. There we go. And I am going to use y and x because those were the variables in the table. So I'm going to carefully write this down. Do I have a typo? I feel like this is supposed to be 13 or something. Let me double check again. Did I not catch a typo in here somewhere? 22.3, 25.5, Maybe I'm just remembering my problem incorrectly from, or my numbers incorrectly from, okay. Oh, no, wait, right here, see? See? Okay. Change that to 23. Sorry, that is going to change my numbers slightly. All right, so let's fix that. I was going to say, I just did this last bell, and I thought I had a 13 there. There we go. Now, that's a case where I only knew I did something wrong because I've done this problem before. What if I do that on the AP test? Yeah, I'm kind of out of luck, sort of, for that, which is unfortunate. But we have plenty of questions on our AP test that would not rely on this. So, sure, maybe I missed this point. But questions after that will be things I can do that aren't all just tied to this single model. All right. Approximate the speed at which the gas mileage is the greatest. So remember, the y values are the gas mileage and the x values are the speed. Where would it be the greatest? Well, on this model, it would be at the vertex, at the peak. So let's turn off the points because they're kind of in my way. Do that by clicking the color for the points on the table. And remember, you can find a vertex of a parabola just by clicking near it. If you want that point to stay so that you can write it down, you click on it. So approximate the speed. The speed x is approximately 45.462 miles per hour. It doesn't ask me to give the gas mileage, so I won't, but it would be the y coordinate there. Find the average rate of change between speeds of 15 miles per hour and 45 miles per hour. So average rate of change is a big thing in this class. They will ask us to do it all the time. So you need to start, if you haven't memorized this yet, it just means find the slopes between those 2 points. So the point when x is 15 and the point when x is 45. So this would be like y of 15 minus y of 45. You can subtract in the other order if you want. But now that I've done that, I've got to do over 15 minus 45. This is just change in y over change in x. And I can let Desmos do most of the work for me as well. Remember, you can paste this equation into the next line by clicking this. Now, I don't want to have to keep copying this and subbing in x's, so I don't think Desmos will let you say y of something. So instead, let's call this f of x. Desmos does understand that function notation. And then down here, I'll say, give me a fraction, f of 15 minus f of 45 over 15 minus 45. So this is my little answer here. And so I'm just going to say approximately 0.254. What would the label be on this? Remember, in general, slope is y per x. So y is measured in miles per gallon, and x is measured in miles per hour. I'm using p for per instead of a divided sign just so I don't have a million fractions going on. So miles per gallon per miles per hour. Strange, but that is what the label would be. Use the model to estimate the speeds, the x's, at which the gas mileage, the y, is 26 miles per gallon. So they're asking me to set this equation for y equal to 26.5, and that happens when x is approximately. Now, the long way to do this is set this equal to 26.5, subtract quadratic formula with these terrible decimals. The easy way to do this is you've already got f of x graphed. You can graph the line y equals 26.5, and you can solve by graphing. Solving with quadratic formula is just solving algebraically. Solving by graphing is just finding the intersection points. That's what you're solving by graphing. You're getting the same answers. So let's report those two x values to 3 decimal places. So one speed is 23.565 miles per hour, or you could say mph. The other is 67.358. Remember, we have to round to 3 decimal places, and we have to round correctly to 3 decimal places to get full credit on our AP test. All right, the next table shows revenues in billions of dollars for Netflix Incorporated, 2010 to 2017. Use a graphing utility, Desmos, to create a scatter plot of the data where t equals 0 represents 2010. So 0, 1, 2, all the way down to 7. Use the regression feature to find a model that best fits the data. I'm just going to X all of this stuff that I had here. I want to start a new table. And again, 0, 1, 2. I'll start filling in numbers for you. Make sure it goes to 7. and then fill these in. I'm going to see if I can do a better job of checking my answers, or checking my data points, I should say. All right, here we go. Boom, boom, boom. That looks right. Zoom fit. There they are. I see a little bit of a curve happening here. Regression. Linear regression, we've done lines of best fit like this. R is pretty close to 1.9608. The great thing about Desmos is you can just change this to quadratic and see if it looks better on the graph, and see if this R squared, because it won't show R, see if R squared gets higher than 0.92. 0.9903. So actually quadratic, and it looks like it fits closer to more of the points as well. So I'm going to go with the quadratic. Right now we're only deciding between those two. So let's write down this model. So this is, let's see, variables. Revenue is still Y. Instead of X, I'm going to use T. So Y equals 0.169405 T squared plus 0.070119 times T plus 2.5575. Comment on its strength. This is better than linear because the graph fits closer to more of the points. Its R squared is higher, which is related to correlation. I'm not going to write that down. You won't have to write that down for me, and you probably won't need it for your AP test. Approximate Netflix Incorporated's revenues in 2018. So that would be Y of 8. We're plugging 8 into this equation. Two easy ways to do that. First, copy the equation into the next line. You can either change this to an 8 and this to an 8 squared, or I just like doing f of x, because what if I forget to put an 8 in somewhere or whatever? So change it to f of x and then do f of 8. That's my preferred method. You can do it however you want. So my answer here is 13.960. What is my label? Y is measured in billions of dollars. So I can write $billion. What type of concavity does the model show? The model is the quadratic curve here. This is concave up. So the graph is concave up. Now, this is typed slightly different. Is the rate of change increasing or decreasing? Ignore my stuff about the rates. Remember, we talked about this in chapter 1. When a graph is concave up, the rate of change is increasing. What do we mean by that? The slopes are going from negatives on the left to closer to 0 at the bottom, to then positives. Those numbers for the slopes, the numbers are increasing. All right. Now, everything else we do will be non-calculator. So let's take a look while we're on this page. Flip to the next page. Take a look at this AP problem. They love giving us this problem. This is guaranteed to be either in your multiple choice or part of your free response, or maybe even just both. So you're given a table. All right. It's not obvious to me what this graph looks like, and I don't have access to Desmos to just look at it and see if it's curved or linear. The table shows values for function g at selected values of x. Which of the following claim and explanation statements best fit the data? So take a look at your options before you do this. G is best modeled by a linear function, a quadratic, a quadratic. What's the difference between the two? So I need to decide linear or quadratic. Let's take a look at the reasoning. The rate of change over consecutive equal length input intervals is constant versus the change in the average rates of change is constant. And that's the same here. Is it the rate of change is constant or the change in the average rate of change? All right, well, how do we know? If this is a linear function, the slope between any 2 points would be the same, right? So let's start calculating slope. Let's call that AROC. the average rate of change between these 2 points, use these 2 points. It would be 78 minus 53 over 1 minus 0. Nice thing about this table, the x's are going up by 1, so we're really just subtracting y values. 78 minus 53 is 25. So this first average rate of change was 25. Now find the average rate of change between the next 2 points, so from 1 to 2. So 97 minus 78 over 2 minus 1. 97 minus 78 is 19. Already, I know this is not linear because the slope is not the same. If it's linear, I should get 25 for every single one of these. So A is out, B is out, not linear. Is this quadratic because the rate of change is constant? This is the rate of change. Is this constant? No, it went from 25 to 19. So I know that it's not the rate of change is constant. It's the change in the rate of change is constant. I want to show you what that means because sometimes we'll have to go further than quadratic. So let's finish finding these slopes, even though I know that they're not constant. You still need them. So the next set of slopes is from points 2 to 3. So 110 minus 97 over 3 minus 2. That's 13. Last one. Slope between points 3 and 4 is 117 minus 110 over 4 minus 3. That's 7. The rate of change is definitely not constant. What's the change in the rate of change? That's just saying find the change from 25 to 19. What's the change from 19 to 13? What is it from 13 to 17? So 19 minus 25 is negative 6. The order matters there. You're going down 6. 13 minus 19 is negative 6. 7 minus 13 is negative 6. The change in the rate of change is constantly negative 6. So you can think of this as the second rate of change, right? The change in the rate of change. That's constant. If the second one is constant, it's quadratic. What if these were different numbers? Then I could find the third average rate of change. And if those are constant, if the third one's constant, it's cubic. If the fourth one is constant, it's degree 4, etc. They haven't gone higher than degree 4 on us, I don't think, but you never know. Okay, now let's go back to our more traditional quadratic content. So beginning of these notes. This is stuff that you did in Algebra 2. I'm just reminding you how to do it. First off, we need to know what a polynomial function looks like. Polynomial has all of these coefficients. And the coefficients, none of them would be 0 here. The function is given by this, where you have all these little x's with all these variables with exponents on them. The exponents have to be positive numbers, whole numbers, etc. That's a polynomial function, degree n. Degree n means n is the highest exponent. So a linear function is degree 1, a quadratic is degree 2. And we're focusing on quadratics today. So here's a quadratic function in its general form, ax squared plus bx plus c. We're focusing today more on the equations in their vertex form. So take a look at this parabola. Let's label the parts of the parabola. Like down here is the vertex. We often call this vertex HK because of how we write vertex form. Vertex form, or standard form, is written like this. Y equals A times x minus h squared plus k. The reason this is called vertex form is you can clearly see what h and k are in the equation. There's also on a parabola something called the axis of symmetry. Axis of symmetry. And the axis of symmetry would always be x equals h because it's a vertical line that goes through h in the vertex. This is helpful because if you're graphing a parabola, you can easily plot a point here and then reflect across the axis of symmetry. There are two ways to convert from a general form equation like this into a vertex form so you can more easily see the vertex. One is complete the square. I'm going to be honest, we are not required to complete the square in this class, and for the AP test, I mean. And honestly, it's really only useful for finding the centers of conic sections, which we also don't have in AP Pre-Calc. So I'm going to rely on the vertex formula, which is much easier to use. I do want to show you how to complete the square because I know that you learned this in Algebra 2, and some people prefer this to the vertex formula. The vertex formula, by the way, is just complete the square put to a formula. Anyway, we're going to do number 1 with complete the square, and then we're going to do number 2 with vertex formula. So complete the square is this. You have to begin by factoring a 2, in this case, or whatever's in front of x squared, out of the first two terms. The reason this is called complete the square is because you're trying to add something to this equation that makes this a perfect square trinomial that factors into x plus something squared. What is that special thing that you have to add? It is b over 2 squared. But again, it's only b over 2 after you factored the a that's out in front, after you factored that out. So ours is 2 times x squared plus 4x. So 4 divided by 2 squared is plus 4. Now, you can't just go adding numbers to an equation without changing the equation. So if I've added a number to the equation, I need to balance it out by subtracting it as well. I did not just add 4, though. I actually added 2 times 4. I added 8 to this equation, so I balance it by subtracting 8. So this is 2 times, this factors into x plus 2 squared. 7 minus 8 is negative 1. And this is vertex form of f of x. The vertex would be, instead of x minus h, this says x plus 2. So h is negative 2. Instead of plus k, it says minus 1. So k is negative 1. I would do the same thing with this one. I would have to factor a negative out first. Instead of doing this with complete the square, to keep these notes shorter, I would like to skip to the vertex formula. Now, I'm not going to prove the vertex formula here with complete the square, again, just to keep these notes shorter. So remember, we are trying to get vertex form, which is this. How did we find a when we completed the square? We factored out an a. I'm sorry, how do we find h when we completed the square? We factored out an a. We divided by 2, squared it, and then we factored this. Well, look at what this factored into. Before I squared it, this factors into b over 2. So x plus 2 squared, that was what 4 divided by 2 was. So this will always be b divided by 2a, and then we put a negative in here because, remember, when this was x plus 2, my answer for h was negative 2. And if this were x minus 2, my answer for h would be positive 2. So h is going to be the opposite of b over 2a. So to find h in the vertex, you always calculate opposite of b over 2a. What is the k? Well, remember, k represents a y value when x equals h. So if I know what h is, I get a number for h, I should just be plugging that in, whatever that comes out to, into the function, and that will give me k. So let's do that for number 4. So instead of doing number 3, you can try it on number 3, but we already did that with complete the square. So let's do this just on number 4. All right, so h should be, and this is a, this is b, this is c, should be the opposite of b over 2 times a, which is negative 1. This is 3 over 2. K is equal to g of that answer, 3 over 2. K is just the y coordinate when h is 3 over 2. So that's negative, and then I square 3 over 2, 9 over 4, plus 3 times 3 over 2 is 9 over 2, plus 5. I need to do a little bit of common denominator work here. 9 over 4 plus, let's make this 18 over 4. Let's make 20 20 over 4. This adds up to 9 plus 20, so 29 over 4. Okay, now what about my equation? G of x equals, what's a here? A has to match when it was in this form. A has to match that. So I had a negative right here, so I need negative x minus 3 over 2 squared plus k, so plus 29 over 4. You will have to deal with fractions, but I think this fraction work is a little bit easier than doing complete the square with fractions. All right, let's take a look at this one. Given the vertex and a point on the parabola, write the equation of the quadratic function in both standard and general form. I don't want to do general form. I just want to do standard form, which is vertex form. All right, remember, vertex form is y equals a times x minus h squared plus k. These problems are pretty straightforward. Basically, you have almost everything you need to write this equation. You have a vertex, which is an h and a k, so go ahead and label these. You have a point, which represents any x, y on the graph. So right now, if I have the vertex, I have this much of my equation, x minus 1 squared plus 2. The only thing I do not know is what goes in front. What is the a? Is it 1? Is it negative 1? Is it 15? 2/3? Whatever. So what it is not is the slope. It's not the slope between these 2 points. Instead, we need to plug all these points into this formula. So instead of y equals, it's negative 6 equals a times x minus h, 3 minus 1, squared, plus k, plus 2. Now just do some math and solve for a. So subtract 2. This is 2 squared. Divide by 4. A is negative 2. That's the missing piece to my equation. So instead of y equals nothing, x minus 1 squared, it's negative 2 times x minus 1 squared plus 2. Same thing for this one. Vertex is hk, point is xy. So set it up with this formula here. Y equals, so negative 4 equals a times negative 1 minus 3 squared plus k plus 1. Subtract 1. Clean this up. This is negative 4 squared, which is 16. Divide by 16. It's okay to get an ugly value for a. We're not graphing this thing. Now I know it's y equals negative 5/16 times x minus 3 squared plus 1. Last thing to learn today is the quadratic formula. So again, if you want to see where the quadratic formula comes from, I'm just going to say Google this on YouTube. I'm trying to keep my video a bit shorter here. We're not going to use complete the square to derive the quadratic formula. I am going to explain what we use it for, though. So if I want to solve ax squared plus bx plus c when it's equal to 0, it has to be equal to 0 to use this. To solve for x, I can use the quadratic formula. It's x equals the opposite of b plus or minus square root of b squared minus 4 times a times c, all over 2a. You need to memorize this formula. This solves any quadratic equation that's equal to 0. Whether it factors, whether you could have used square root method, or whether it doesn't factor. The thing about it, though, is that it's easy to make mistakes, and it's easy not to simplify it all the way. So I don't want you to only use quadratic formula, but I want you to be able to use it when you need it. So here's my example. Find the x-intercepts of the quadratic function. X-intercepts are when your equation is equal to 0. So for this first one, if I think that the problem factors, I should just try factoring it. We do factoring speed quizzes every week. You did them every week last year in Algebra 2. We've been factoring for so long. The idea is that that should be faster than doing quadratic formula. So factor this one. If you can't figure out how it factors, then of course you can use quadratic formula. I'm going to factor out a negative. I have to do that out of every term. This is just a little trinomial here. It's got to be x minus 4, x minus 2. So the x-intercepts are positive 4 and positive 2. I would get those same answers if I did quadratic formula. I just have to do the math correctly. On number 8, if I'm missing the middle x term, meaning b would be 0, I could still put 0 in for these quadratic formula b's here, but it's faster to do square root method. If there is no x term here, all you have to do is when you set this equal to 0, you are able to isolate the x squared term without having an extra x in there. So you're allowed to square root both sides. Remember the plus or minus, though, and simplify your radical. Plus or minus 2 radical 6. You're not allowed to use this method if you have a trinomial because you can't square root individual terms, so it only works for this case. Finally, on this one, it doesn't seem to me like any combination of 2's and 4's and 2's are going to get me 3 in the middle. If it's not obvious to me how this factors, that's where I use quadratic formula. So we're setting this equal to 0. The a is 2, the b is negative 3, the c is negative 4. X equals the opposite of b, positive 3, plus or minus square root of negative 3 squared is 9, minus 4 times a times c. The 4 is built in out here. All over 2 times a, which is 2. Be careful, it's the math underneath the square root that people tend to make mistakes on. So I look at it like this. Ignore the 9 for a second. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. So underneath the root, I have 9 plus 32. So 3 plus or minus radical 41 over 4. If I could simplify the radical, I would, but I can't. So those are the x values. All right, that finishes up our day of quadratics. We will work more with these quadratic applications and regression and all of that. Please come into office hours if you need help with any of this.